Welcome back to Algebra 1 with Miss Betsy. Today we're going to be discussing how we multiply a polynomial by a monomial, and we're going to see that that's really a very straightforward, simple operation to carry out. The text that I'm using to drive this video looks like this. It's Algebra 1 for Christian Schools, 2nd edition, published by Bob Jones University Press. If you are using this exact text, we're in section 8.4 on page 332, but it doesn't matter what edition or even what publisher you're using. The way that we learn how to multiply polynomials by a binomial here is exactly what you're going to do regardless of where you learn your algebra. So let's go ahead and pray and see what our lame joke is, and we'll get started. God, thank you for another day of life that you've given to us. Thank you for a spring-like day in the midst of winter here in Northeast Texas. And I ask that you would help us to focus today on the things that you'd have us to learn and to be very much aware of how you are with us always. I thank you that you love us. In Jesus' name, amen. All right, jokes for today. What do you get when sheep do karate? And oh, I saw the lamest old karate movies, complete with the strange sounds and the very stilted behavior. Last night, I was just about to die laughing. Anyway, what do you get when sheep do karate? You get lamb chops. And then, what happened to the mouse when he fell into the bathtub? Well, he came out squeaky clean. So, multiplying by monomials is a very straightforward operation. What you need to remember to begin as we start this, we have, what do you do when you are multiplying? That's interesting. This is a new marker and it doesn't hardly work. Algebraic expressions that have the same base but differing exponents. Here we have a base of x, the exponents that we're multiplying these two together, and I think I'll just go to the other side of this marker, see how this works. And we're going to have x squared times x cubed. Interesting, that one is no better, so my very classic thing that y'all look forward to, there goes a bad marker. Okay, we'll try this trusty black one right here. If we have x squared times x cubed, that answer is not equal to x to the 6th. Because what you do when you're multiplying variable expressions that have the same base, you simply add the exponents. So rather, when you have x squared times x cubed, you get x to the 2 plus 3, or x to the 5th. And we're going to use that feature along with knowing how to multiply together constant terms to get 10, and the fact that multiplication is commutative, which means that the order in which you multiply factors together doesn't change the resulting product. We're going to combine these three pieces of information when we see how we multiply by a monomial. So let's first take example 1. We have 3x squared times 5x. We have 3x squared times 5x. Now right here I only have one actual visible indication of multiplication. We have this raised dot here in the middle. It means that we're taking this first factor of 3x squared and we're multiplying it with our second factor, which is 5x. However, we've learned that when we have a coefficient in front of a variable, the coefficient of course is the 3, the variable is x squared, that what this means is 3 times x squared. So I'm going to take a second just to add in a couple of extra raised dots to indicate multiplication. So we actually have 3 times x squared times 5 times x is what this expression up here actually says. Now I reminded you that multiplication is commutative. It means that it doesn't matter what order you mix those factors up in, your product is going to be the same. So we could actually move this around. 3 times 5 times x squared times x. We now have, what's 3 times 5? That's very obvious. That's 15. And then we have x squared times x, and that is not equal to x because when you multiply variables, you add the exponents. The base is the same, you add the exponents. When you can't see an actual exponent here by this x, you know it just means 1, because all this variable with an exponent of 2 means is that when you have x squared, the 2 means use the base, which is x, as a factor 2 times. So when we have a variable without an exponent on it, it just means we're using that variable as a factor 1 time. All right? 3 times 5 is 15. X squared times x is x cubed. So 3x squared times 5x is 15x cubed. I broke it apart, put these raised dots in there, moved my factors around literally so that we had 3 times 5 is 15, x squared times x is x cubed. But you don't need to do that at all. The only reason I took the time to do that right now is to illustrate to you why we are allowed to simply say, if we have monomials that we are multiplying together, let's say that we have 4y cubed times 12y to the 6th, that we can look at this and immediately say that the answer is 48y to the 9th. Because multiplication is commutative, so we can multiply the constant terms together, or the coefficients rather. The coefficient of 4 times 12 gives us 48. You multiply y cubed times y to the 6th. You add those exponents together to see that we're going to use y as a factor 9 times. And right here is the solution to our problem, 4y cubed times 12y to the 6th. So that's the basic way that you're going to multiply by a monomial. Multiply coefficients together, then multiply your expressions that include a variable in it by adding the exponents. So what makes this a little bit harder? Well, in truth, not a whole lot. But let's do one more simple one right here before we expand it just a tad. And let's say that we have negative 8. If I can make my glasses work. X squared y z cubed times xy z squared. X, y, z squared. Nothing mysterious here at all. First we're going to multiply the coefficients together. Negative 8 times 1. We have a negative 8. Going to deal with our x's first. X squared times x, x cubed. Y times y, y squared. Z cubed times z squared is z to the 5th. It's hard to get much more simple in algebra than multiplying monomials together, but the kicker comes in if you don't remember how you multiply exponents. When you're multiplying exponentials, you add the exponents. Thus we have we have z to the 5th rather than z to the 6th. Okay, now let's expand this just a little bit. And let's say that we have a rectangle. And this would be an example of a word problem that you might have, where you have a rectangular garden, and the length of that garden is 8 units longer than the width of it. So the width of the garden would be x. The length of the garden would be the width of the garden plus 8 additional units. So how in the world are we going to multiply that? Let me see what they are doing. The length, the width. Okay, I'm going to change it. I really wanted to keep it just with an x. I like my plan better, but I'm going to do their 4 just in case that you are tracking with the book. If the width is, let me see, what in the world am I doing? You know what? Back to what I said. You can look in the book at their own example. And we're just going to go ahead and deal with mine, because this is a real life word problem. You want to set up a garden. How much, what are we going to have if we want the width to be 8 units less than the length, or the length right here is 8 units greater than the width. And then what's the area of this going to be? How do you find the area? Well, the area is length times width. So the area can also be width times length, right? Doesn't matter what order you have your factors in. So you have area is equal to x times the quantity x plus 8. You guys are well aware of how to use the distributive property. So the area now is x times x, which is x squared, plus x times 8, which is 8x. And what we've done here is we have used we have a product of x squared plus 8x that we arrived at by multiplying the monomial x with the binomial x plus 8. And we did that, we were able to accomplish that by using the distributive property. So let's go ahead and look at another example and see what we have now. If we had 2x times 4x plus 5. Let's see what happens. Where'd my eraser go? 2x times 4x plus 5. The quantity 4x plus 5. Simply going to use our distributive property. 2x times 4x. And I'm actually going to write it out this time. I have 2x times 4x. Use this sign. Plus 2x times 5. Now we're going to multiply these together. 2 times 4 is 8. X times x is x squared. We have 8x squared plus 2 times 5 is 10x. 8x squared plus 10x is what our resulting product is when we multiply a monomial, 2x, times the binomial here, which is 4x plus 5. So what's going to happen if we include a trinomial in our multiplication process? Let's say that we have 3x times the quantity x squared minus 7x plus 8. Well, we can still use the distributive property. We can multiply this in our heads as we go. Do this if you're comfortable at this level. If you're not comfortable doing it in your head, take the time to write an extra step. We have 3x times x squared is going to give us 3x cubed. Minus 3x times 7x is 21x squared, plus 3x times 8 is 24x. Well, how can I be certain that that's correct there? Well, let's go ahead and write what we would call partial products. 3x times x squared minus 3x times 7x plus 3x times 8. What do we get when we multiply these partial products together? 3, and then we have x times x squared is x cubed. 3 times 7 is 21. X times x is where we get the x squared because we've added our exponents. 3 times 8 is 24, and then we have x. So this would be how we would multiply the monomial against the trinomial if we were doing it horizontally. But you can also multiply polynomials, which of course include monomials, in a vertical fashion. Let me show you this by using our last example here on our book. In our book, rather. Example's not hardly on our book. And I'm going to use a little bit longer problem. And we want to multiply 2xy squared by a 4-term polynomial that is 3x minus 8xy plus 5y plus 3z. We want to look at this and we say that we have 4 different terms, so there's nothing that we can combine. And this is just a polynomial. We don't call it a quadrinomial because it has 4 terms. Our special names end with monomial, binomial, trinomial. Anything with 4 or more terms we just refer to as a polynomial. And then we wanted to multiply it by 2xy squared. We're going to set this up vertically just in a very similar manner to how we set up 2x squared. Let me verify that 2xy squared. 2xy squared. This is set up very similarly to how we would simply do multiplication just with numbers. Going to begin here, but our signs go together. Positive 2xy squared times a positive 3z. 2 times 3 is 6xy squared z. X, y squared, z, it's positive. So that plus has to go in front of the term. We're building our polynomial backward. 2 times a positive 5 is a 10x y squared times y is y cubed. 10xy cubed. 2xy squared times a negative 8xy. 2 times a negative 8 is a negative 16. X times x, x squared, y squared times y is y cubed. We have one last pair of terms that we want to multiply together. 2 times 3 is a positive 6. X times x is x squared, y squared. So the product that results when we multiply this polynomial with this monomial is this expression right here. Now let me just go ahead and redo this multiplying horizontally and see if I end up with the same answer. And you know I better. So here's one answer. Now we're going to multiply by 2xy squared. 2xy squared times this quantity. And let's see what I end up with. Take this out, and I'll write my answer in brown. 2 times 3 is 6. X times x, x squared, y squared. Positive 2 times the negative 8 is a negative 16. X times x, x squared, y squared times y, y cubed. 2 times a positive 5 is plus 10. X, y squared times y is 10x, y cubed. Positive 2 times positive 3 plus 6 x y squared z. X y squared z. Now let's compare this polynomial with this polynomial. I'm sure you've already done it, but I'm going to go through it now. 6x squared y squared minus 16x squared y cubed plus 10xy cubed plus 6x y squared z. And you see that regardless of whether you multiply horizontally or you multiply vertically, you end up with the same resulting polynomial product. Do it whichever way is most convenient to you. I never do that vertical multiplication ever if I'm multiplying by a monomial. Sometimes I will if it's a binomial times a trinomial. And we'll see that as we move on, that there are times that it's very valuable to multiply vertically. But my recommendation to you for this section, anytime you're just multiplying by a monomial, simply distribute. I think it's easier to keep up with, takes less space. And that's the end of section 8.4. So this is an easy one for you, and I'll see you next time.